We will be performing a lab in which we use different magnets of different strengths to test how each affects the density of ferrofluid, a magnetic liquid metal. We hypothesized that the greater the strength of the magnet, the greater the density of the ferrofluid. Polarization of ferrofluid comes from van der Waals forces. The purpose of this lab, then, is to demonstrate how van der Waals forces affects the polarity of ferrofluid and also to practice finding the density of a liquid. To find the density of ferrofluid after it is affected by magnets of different strengths, we must subtract the mass of the ferrofluid alone by the mass of the ferrofluid with attached magnets. Because ferrofluid is a poisonous liquid and can be irritating to the skin, it is vital we take safety precautions. Notice Michael is wearing goggles to protect his eyes and is putting on gloves to protect his hands from the ferrofluid. We will find the mass of an empty cup, and in order to find the mass of 4 milliliters of ferrofluid, we will have to subtract the mass of the empty cup from the mass of 4 milliliters of ferrofluid inside the cup. Michael is adding 4 milliliters to the empty cup. However, in order to make sure that it is 4 milliliters, we must add it in drop by drop instead of pouring it in. We found that the mass of the ferrofluid is 7.16. These are the strongest magnets we will be using. They weigh 32 grams. Michael is now weighing the mass of the ferrofluid when it is attached to a magnet. He will have to subtract 7.16 from this to find the total. Repeat these steps with a smaller magnet, which weighs 12 grams, to find the mass of the ferrofluid when it is affected by the smaller magnet. Density is equal to the mass of the ferrofluid affected by the magnet divided by 4 milliliters. Using the strongest magnet, spikes are caused by the dynamic interaction between van der Waals forces, gravity, and surface area. Smaller magnet does not have as great as an effect because it does not attract the polarized bonds within the ferrofluid as much. After having conducted the experiment, it was found that the mass of ferrofluid with the stronger magnet was 20 grams per centimeter cubed, whereas the mass with the weaker magnet was 16.68 grams per centimeter cubed. Using the volume as a constant, which was 4 milliliters, we found that the density of the magnet that was stronger was 3.21 grams per centimeter cubed, while the density of the magnet that was weaker was 2.38 grams per centimeter cubed. In this experiment, we discovered that our hypothesis that the greater the strength of the magnet, the greater the density, was actually correct because magnet number 1 produced a stronger density than magnet number 2. This experiment served to prove how van der Waals forces affect the polarization of magnetic substances, which related to our discussion of dipole-dipole forces and van der Waals forces at the beginning of the year. Also, it showed how density can be found, and this was a large unit that we covered at the beginning of the year as well. Ensure that ferrofluid does not get on anything because it stains a lot. Don't get it on your hand and don't get it near any other magnet because unless you have a stronger magnet, you will not be able to get it off. Remember that ferrofluid is a poisonous substance, so it is necessary to properly dispose of it by not draining it down the sink. Also, we must put back the balance and other such materials where they go or else Miss Hearn will kill us. And that concludes our experiment. I hope you learned about the valuable lessons of ferrofluid.